Next, we're going to study the connection between polar and Cartesian coordinates. We can do this using our right triangle trigonometry. Remember that if a point has Cartesian coordinates xy, so that means we're over x and up y, and of course if y is negative then we're down, etc. So over x, up y. In polar coordinates are theta, so this means we're out a distance of r from the origin and we make an angle of theta with the positive x-axis. So if I draw in the right triangle that corresponds to over x and up y, so this distance is x and this distance is y, I see, for example, if I do the cosine, excuse me, of theta, I get adjacent over hypotenuse, so x over r, which tells me that x is r cosine theta, which is this first equation that I've got here. Similarly, if I do sine of theta, then we get sine of theta is a opposite over hypotenuse, which gives us y equals r sine theta, which is our second equation. The Pythagorean theorem tells us that x squared plus y squared equals r squared. And finally, we see tangent of theta is opposite over adjacent, so tangent theta is y over x. So these four equations can be helpful when you're moving back and forth between polar and Cartesian coordinates. Let's look at a few examples of doing that. So remember this earlier point that we plotted for pi over 6. So pi over 6 means we're 30 degrees from the axis, so around here, and we're out 1, 2, 3, 4 units from the origin. So this is the point with polar coordinates for pi over 6, so we're out a distance of 4, and our angle is pi over 6, or 30 degrees. So I want to find, these are my r theta coordinates, I want to find my xy coordinates, so I know that x is equal to r cosine theta. So we get 4 cosine of pi over 6, and draw out your unit circle or your right triangles. Remember, cosine of pi over 6 is root 3 over 2. So this gives us 4 times root 3 over 2, or 2 root 3. So we're over 2 root 3. And to get our y coordinate, we will remember that y is our sine theta, which is going to be 4 sine pi over 6. Sine of pi over 6 is a half, so we get 4 times a half, which is equal to 2. So we're up 2. So our Cartesian coordinates, our xy coordinates, are 2 root 3, 2, meaning we're over 2 root 3 and up 2. And of course we can check that this is reasonable. For example, if either of our x or y had been negative, we would have known that we made a mistake. So again, our key relationships here were x is our cosine theta and y is our sine theta. All right, let's do another one. So I want Cartesian coordinates of the point with polar coordinates -2, -5 pi over 6. So here both our r and theta are negative, so let's figure out what to do here to plot it first of all. So -5 pi over 6 means I go in the opposite direction, so down, and I'm just pi over 6 away from a full pi all the way around. So we get our angle 5 pi over 6 is this guy. So here's 5 pi over 6, which is the same as, so it may be useful to remember your connections with degrees to visualize some of these. So this is negative 150 degrees, so 30 degrees away from -180. So r equals 2 would put me 2 units out on this line, but I want r is -2, so I want to flip on the other side to get r is 2. So I want to flip around on the other side, so my r is going to be 2 units on the other side. Okay, so when I do this, so I see that both my x and y should be positive. So let's plug into our formulas. So x is r cosine theta, so -2 cosine of -5 pi over 6. So what do we get when we do cosine of -5 pi over 6? So again, you want to remember your unit circle. The cosine of -5 pi over 6 is negative root 3 over 2. So we get -2 times negative root 3 over 2, which just becomes the square root of 3. So our x-coordinate is root 3, so we're going to be over root 3. So I'll put in our x, y coordinates are over root 3. Our polar coordinates of this point were minus 2, minus 5 pi over 6. So these were the polar, and now we're getting the Cartesian. So, and now we'll get our y coordinate. So we get y is r sine theta, so minus 2 sine of minus 5 pi over 6. So sine of minus 5 pi over 6, again, draw out your unit circle, is minus a half, so we're getting minus 2 times minus a half, so which simplifies to 1. So our y-coordinate is 1. So this point is over root 3 up 1. X is root 3, y equals 1, corresponds to the polar point minus 2 minus 5 pi over 6. Now, how would you have written, just as an exercise, how would you have written minus 2 minus 5 pi over 6 using a positive radius? So same thing, if instead of going minus 2, if I want r to be plus 2, I would say, okay, I need to be on this positive angle. So this positive angle is just pi over 6, or 30 degrees, so 2 pi over 6. And now notice that if you do our equation r cosine theta with positive 2 and pi over 6, we get the exact same thing. So 2 cosine of pi over 6 gives us 2 root 3 over 2, or root 3, and similarly, so we get root 3 here, and if we do y equals to sine of pi over 6, sine of pi over 6 is a half, so we just get 1. So if you like to work with the positive radius better, you can first rewrite your polar point in this way, and then use your x as r cosine theta, y as r sine theta, or you can just leave it as the original polar, so this was r is minus 2, theta is minus 5 pi over 6, and plug into your equations that way. I do recommend that you first sketch the point so that you have an idea. Again, here x and y we see from the picture should both be positive, so I recommend that you sketch the point to get an idea if your final answer makes sense.